Alright, so in the last video we talked about sequences and series, and now we're going to get to a very specific type of sequence and series, arithmetic sequences and series. And again, partial sums is just another word for series. So arithmetic sequences and arithmetic series is what we're looking at here. So first we're going to start with a definition. What is an arithmetic sequence? So obviously a sequence is a pattern. We learned that in the last section. An arithmetic sequence is essentially a pattern where all of the terms are separated by a common difference. So you can think of it as going up by 2 every time, or going up by 7 every time, going up by 5/4 every time. There is a common difference that you're always going up by to get to the next number in the pattern. All I got to do, I got to add this amount. Sometimes it's a negative amount. Sometimes you're actually decreasing. That's essentially the idea of an arithmetic sequence. Always increasing by the same amount. And one way to check if you're arithmetic is you take all of the terms, any consecutive terms, if you subtract them. So these are consecutive terms. These are consecutive terms. These are consecutive terms. Even using n's, they're consecutive terms. All of those answers, if you subtract them, need to be the same exact number. That number you get is called D, which is known as the common difference. That's actually going to be a very important vocabulary word going forward. So here are some examples of arithmetic sequences. Because if I was just to list out the numbers in these patterns, this would be 7, 11, 15, 19, 23. You can see every single time the common difference is 4. And notice 4 is part of your problem. Here, if I was to list some of these out, this would start with 2, negative 3, negative 8, negative 13, negative 18. The common difference here would be negative 5 because it's decreasing by negative 5 every time. A little trickier here. Let's see, this would be 1, and then you would have 5/4. 5/4. Then it would be 6/4, 7/4, 6/4, 7/4, 8/4, and of course I didn't reduce any of these, 9/4. The common difference here is 1/4. So there is a little bit of a pattern here. The common difference is essentially the multiplication portion of your pattern, of your formula. That's where the common difference comes from. Now, if you notice this number does not appear anywhere in our sequence, in our pattern. Notice the 7 actually doesn't appear, so it's actually a little trickier to calculate that other number when you're coming up with these formulas. So, an arithmetic sequence has the form an is equal to dn plus c. So we already defined d on the last slide as the common difference. Alright, so d is the common difference. And to calculate c, this is the now some people there's lots of ways to calculate c, but one of the ways to calculate c is to do the first term minus the common difference. And if you go back to the last slide, if you pause here, I'm going to go back for a second. So I go back and I actually do take my first term and subtract away my common difference, 7 minus 4, I get 3. That's the number that's in the formula. If I do my first term, 2 minus my common difference, which is negative 5. So notice the double negatives here. That actually means plus, and I get 7, and that 7 works out in here. Now, this is not technically in the form that the other one is, so I would put this one as a little bit of not quite in the same form. You would need to write this as 1/4 x plus 3/4 to get this to work. And if you notice that the first term, 1 minus the common difference, that would be 3/4, and that would be part of this formula right here. So that's how we can calculate c. So arithmetic sequences, it's essentially going up by or going down by, whether it's going up by 5s or going up by 2s or going up by negative 6s, whatever. It's always moving by d, either increasing or decreasing. Right, so what we're going to do together is find a formula for the arithmetic sequence whose common difference is 3 and whose first term is 2. So what they're telling you, common difference is 3 and that the first term is 2. Well, you need to come up with a formula for an. All right, well, because dn, the common difference is 3, And the question is, what's this C value? And again, we have that formula for C. It's the first term, which they gave us, minus the common difference. So C is -1. So I can go right here and say this is my formula. Whether you write plus -1 or -1, this works. And if you don't believe me, check what your first term is. A1 would be 3 times 1 minus 1. That's 2. All right, you could check your second term is 5. Your next term is 8, 11, 14. It's going up by 3 every time. We got it. All right, so it's not always that easy. Here, you are given the fourth term, if you prefer to think of it like that. The fourth term of an arithmetic sequence is 21, and the 13th term is 66. Find the first 13 terms of this sequence. Okay, so to be able to do this, you need to figure out what the common difference is, and all that they gave you is that the fourth term is 21, and that the 13th term is 66. Well, if I'm looking at this, I know that from here to here, I know it increased by 66 minus 21. That's what it went up by. Over a span of 13 minus 4. This, to me, looks like a slope calculation. 45, it increased by 45 over a span of 9 terms. Well, what did it increase by each term? This increased by 5 every single term. So if I know that the fourth term is 21, then I know before it was 16, 11, and 6. And if I needed to go beyond, 26, 31, 36, 41, 46, 51, 56, 61, 66, that's going to be my 13th term, and that's why I needed to write the first 13 terms of. It's worthwhile. I should be able to come up with a formula for this relatively easily because I already know that my common difference is 5, so that's the 5n, and because I know my first term, my C is equal to the first term minus the common difference, which is 1, so that's why I'm going to say plus 1. This formula would calculate any of them on here. If you don't believe me, let's just pick a random one, like A6. That's 5 times 6 plus 1. That would be 31. And 1, 2, 3, 4, 5, 6 term in, 31. My formula checks out. All right, find the seventh term of an arithmetic sequence if the first two terms are 2 and 9. All right, I actually almost think this one could be a little easier because you should know the common difference right off the bat. If the first term is 2 and the second term is 9, then you know that the common difference is 9 minus 2, 7. So the common difference is 7. And in fact, I told you A1 and I told you A2. So to calculate C, that's going to be 2 minus 7. So C is negative 5. So right off the bat, I've given you enough information to come up with a formula. Now, I only asked you to find the seventh term, so could you have actually just kept adding 7, adding 7, adding 7? Yes, but I would prefer to use the formula because then it's just 7 times 7 minus 5, 49 minus 5, 44. It works really well. I mean, obviously you could work it out by hand getting to the seventh term, but if I asked for the 700th term, then it's going to be way easier to have a formula for this. So creating those formulas are quite important. All right, so here's where I want to pause today, and I'm going to leave you with one question. I want you to try it in your notes. I want you to come up with a method, and obviously typing 1,000 digits into your calculator doesn't sound like too much fun. But if I want to know the sum of the first 1,000 integers, that means 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Keep adding all those integers until you're at 998 plus 999 plus 1,000. And all the numbers in between, I want you to add them all together. Obviously, I don't expect you to type them all into your calculator. What would be an easier way that you could calculate it? And I actually would say without a calculator, by hand. No calculator necessary. So see what you come up with, and bring any answers you come up with to class tomorrow. I will see you then.